Hi everybody, welcome to my channel. In today's video, I'm going to show you how you can create and deploy secure S3 buckets in your AWS account. It's important to secure your buckets properly because almost all S3 data breaches occur from misconfigurations that lack proper security controls. When securing your buckets, you should always take a defense in depth approach to protect your data, especially in the cloud. The following tips should be the building block for designing secure architecture around S3. A good secure start would to create a logging bucket, enable a public access block for the account and the individual bucket itself, create strict bucket policies, encrypt a bucket with KMS, and deploy S3 endpoints. The first thing you want to do is you want to create a logging bucket. I went ahead and just created a simple bucket for my configuration. So if we look at the logging bucket here and go to properties, this logging bucket will hold all S3 object logs. So whenever you interact with a bucket, the logs will be sent to this one. One thing to note with your logging bucket is to make sure that you encrypt it with AES 256 and not KMS. Throughout your account, you should use KMS for all your data buckets and they should be unique to each bucket. However, for your logging bucket, it has to be AES 256. And once you have your bucket configured, you want to go back and do the screen here, and that will create our new secure bucket. You want to click create bucket. We want to give it a name. I will call mine okay. Pick a region. Hit next. We don't want to enable any versioning. We do want to do server access logs. Now here we can see we select our logging bucket and any target prefix. So at this point, I just want to log everything. So I don't want to just log a specific path. I want to log everything from this bucket into here. Don't want to set default encryption just yet. Then hit next. Now here you want to block all public access. So this stops you from being able to set public accessible items via their ACLs. And we can see blocked access to buckets and objects through new ACL. So if I were to put a new one on there, block public access buckets granted through any access controls. So it'll ignore this, and block anything granted through new public bucket or access point policies. So this way you don't accidentally make your objects public to the world. It's just an extra layer of security. Then hit next and create bucket. Now that we got logging configured, we're ready to apply a bucket policy to our bucket. Click into bucket, go to permissions, and go to bucket policy. This policy can be found in a gist or a snippet in the description of this video, which will link to my GitLab. There are instructions and more details on this policy there as well. I'm going to explain each policy as I go through the list, and then we're going to apply it. Now here's the complete policy. The first thing you want to do is replace the placeholder value with the name of your bucket. And you can find those through here, which obviously there will be a bucket name here. It does not match what you created. We can see there's a few here. I'm going to do the rest and then I will cut back over. Now that the placeholder values have been changed, we're ready to walk through what this policy does. The first part of our policy, deny public read ACL, denies object and object ACL put operations when the request contains specific ACL actions right here. We can see public read write, and authenticated read write. Now what this does, this will stop anybody from putting an object or an object access control list when the Amazon S3 headers contain these actions. So this way you can't create any public objects from the AWS principles. Our second policy here, deny public read grant, will deny any AWS principal for the same actions above, put object and put object ACL. However, this time we can see when the headers actually grant read include global all users and global authenticated users. Now these two groups, what they actually are, all users and authenticated users. So the ACS URL here, the group's global authenticated users, is any Amazon authenticated user. So if you have an AWS account, this line here will explicitly deny any action from anybody from an AWS account to do the same thing above. So that way you can't change the access control list or put public objects in this bucket. And this is where that defense in depth approach comes in. Explicitly, the bucket can't be accessed by anybody unless you grant it. But by having this line here, you can make sure that if you do grant access to this bucket or other places to write to it, you automatically they do not have the option to write a public object or ACL to the bucket. Now the all users global groups is pretty much saying the entire internet, anybody on the internet can't put an object or put object ACL from these groups. Moving forward, we have two more policies which are real similar to the ones above. However, they're not object actions, they're bucket actions. And what that means is now we deny the public bucket access control list rather than the object itself. So before would be actions to make the object public. Now we want to make sure any action can't make the entire bucket public. And these are pretty much mirrored copy back and forth between the objects and the bucket. And we can see right here, scroll down a little bit, deny public list ACL. The action is S3 put bucket ACL on our bucket. So now we can't put bucket ACLs that contain public read write, or authenticated read. In addition, copied is the one, just like the one above for the objects, we have the same thing here for the bucket itself to the internet and authenticated AWS users to stop them from being able to put bucket ACLs on our secure bucket. Now the final SID we want to put in our bucket policy is to deny HTTP requests. When you have a vanilla S3 bucket, it is entirely possible to get objects from HTTP. You can put an AWS CLI command to no verify SSL, and then it'll use the get objects using the HTTP, and it'll be an unencrypted request. By using this policy here, we can completely stop that from happening. So as we can see, it's the S3 get object, deny all objects in the path with the Boolean value of AWS secure transport false. So this way, it'll deny any actions against this bucket that are the HTTP protocol. Now that our bucket policy is configured and saved, it is to move on to the encryption of the bucket. First thing we need to do is create a KMS key. Let's go over to the KMS console, which can be found under services and then KMS. Once in the KMS screen, we can see I already have one KMS key here configured, and this is for my Terraform state files for my AWS environment. And we're going to be adding another one to this. You want to hit create key. Want to click symmetric. You want to give this an alias. Now the alias I want to give it is the name of my bucket, and you can see why later. Description. KMS key for bucket. You can add any additional tags if you want. I like to always put in a name tag with the name of my resource. It's just a good habit, especially when dealing with a lot of the networking and EC2. It's easy to just create a name and a tag value that automatically populates the name field. I hit next. Now on this screen, you want to pick your key administrator. I'd pick the identity that you are or any particular roles that you and someone else be using to administer this key. You do not want to give administrative privileges to everybody for your KMS key, only the people that would require the ability to be able to perform actions and change the key policy. So I'm going to pick my reserved instance, my reserved SSO access role, and hit next. And then we have select the IAM users and roles that can use this key in cryptographic operations. Now what that means is you can give permissions right now to specific roles and users to use the encrypt and decrypt operation for this key. For me, I am going to just do my administrator role access and then hit next. And we can see here it actually generated a key policy for us. And similar to our bucket policy, we can see that IAM permissions are enabled for the root of the account. And then hit finish. All right, our key's created. Now we're ready to use it to encrypt our bucket. You want to get back to the S3 screen. Services, S3. And once back in here, you want to get to our new bucket. Bucket secure, properties, default encryption, AWS KMS. And then why I picked that alias earlier, now it'll just be easier to find in this dropdown. We can see right here, Divinity Test Bucket Secure, and then hit save. Now our bucket is encrypted with KMS. Now, any services or users that we needed to get objects from this bucket, we would have to make sure that they have permissions to use this key as well. So not only can they not decrypt and encrypt this bucket, they also have to have permissions to use those operations on that key as well. So this is protected very well. Now, the final thing to do in your account would be able to create a VPC endpoint. Now, why you want to create the VPC endpoints is because if you were to make a request to your S3 bucket from, let's say, a Lambda or a Docker container that lives in your AWS environment, if you don't have endpoints configured, the traffic will get routed out to the internet and then back into your account for the request. Now, what you want to do is you want to keep that request internal to your AWS network. And to do that, you have to create a VPC endpoint. Now, the VPC endpoint updates the route tables for your VPC to allow all traffic to route to that specific endpoint in the AWS network. So this way, the traffic never leaves the AWS environment. To do that, you want to go to Services, VPC. You want to go down to Endpoints. Now we're at the VPC endpoint screen. You could already see that I have one configured in my account, but to walk you through the process, we just as simple. We can see some things here that is available. The endpoint type is a gateway, which I won't go to in this video because there's multiple types of endpoints. And then the service name, com.amazonus.east1.s3. This is what our route tables will use to ensure that all the traffic to the service are routed in our account. So you want to go to create endpoint. You want to wait for this page to load. If you go down to the bottom, you'll see that it doesn't hit the S's. You want to go to page 2. And then in page 2, you want to find Amazon East 1 S3, which is a gateway type. You want to click that. You want to find your VPC. Mine is a non-default. It's my VPC that I configured it to be a standard for my use case. After you select your VPC, you will get a description of what will be added to your route tables. You can see here that this will be the target for the endpoint ID. So anything in our route tables and our VPC that we select down here will be routed to this endpoint to make the request to your bucket. You want to go ahead and select the route tables that you want this to be associated with. When you get down to the policy, at this time, I think it's just best to use full access unless we want to scope this down to specific services and users within the account as well. There's more information on this, but for this tutorial, we just want to make sure that our bucket isn't public and no public objects can be put in. So you want to continue down here and add a few tags. I'm going to name mine, name, my new S3 endpoint, and then you want to hit create endpoint. After you click create endpoint and you come back to the endpoint screen, you'll see your endpoint here. It may take a minute or two to become available, but then it'll update here. Once it's complete, you can go over to your route tables, and I will go to my private route table and my routes, and we can see the route table entry here that the VPC endpoint created for the target VPC endpoint, which is active. So now all internal requests from my services and my AWS account will be routed through the endpoint rather than the public backbone.